when an amide is treated with lithium aluminum hydride, the product is actually an amine. Essentially, what appears to have happened is the carbonyl oxygen goes away and is replaced with two hydrogens, both of those hydrogens coming from the lithium aluminum hydride. The way the mechanism works is the way a lot of your hydride mechanisms work is the hydride adds to the carbonyl, electrons go up to the oxygen, and you get this species. Now, one thing this O- cannot do is it cannot kick off this nitrogen. Or if it does, it's actually quite slow because you're exchanging an O- for an N-. N- are really, really strong base, very unstable, and so you're really going uphill in energy. So it's much, much more likely that it goes this way than that way. So this process does not happen. Instead, this O- here, which is basic, it reacts with the LiAlH4, which is a Lewis acid, and it can come on and off of that aluminum. Like so. Now this species here, this nitrogen has a lone pair. What can happen is the nitrogen's lone pair comes down and kicks this oxygen off. This is a reversible process. And you form this. Now, protonated imines are very good electrophiles. And before another amide is reduced, this reacts with a hydride source. And this step is irreversible. It gives the second hydrogen right there. And this is your final product. What the ammonium chloride does is it's essentially part of an acid workup step that helps separate this nitrogen, this amine, from the alumina contaminants. It reacts with each of these hydrides and eventually replaces them with OHs. That can then be, this whole thing can be then filtered off, isolating it from this. Now for the mechanism of the amide, all you need to show is this. This is one of the few times in which you don't need to show the ammonium chloride acid workup step.